Okay, so tomorrow there is a review session from 6:30 to 9:30 in Haynes A02. Okay, it's a different classroom. It's down the hallway in that direction. Okay, different classroom. We'll meet there. Review session. I will be going over all of the answers to the practice final exam. So, have any of you started working on the practice final exam? Okay, so to make this review session worthwhile tomorrow, I highly recommend working through as much of it as you can tonight, but I know that's asking a lot, or I guess during the day tomorrow, not tonight, because we end class and nobody wants to do any more work. But during the day, I would say work on it if you can. If you can't, that's fine. I will go over all of the answers so that during this week that you're studying for the final, you can work on the practice final and compare your answers to what we did in class, okay? The final exam is 1 week from today. I will provide Scantrons. I will provide Z-tables and T-tables to everyone. You need to bring your own calculator, eraser, pencil, things like that, okay? You are allowed 1 sheet of notes, a full sheet, front and back, and that will be that. Questions on either the review or the final or what? Yes?
So for the final, it's mostly going to be what we did after the midterm? So
yes.
How much focus is on like the first couple chapters?
So the final exam is about 50 questions long. I would say there's about 10 questions that come from before the midterm, okay? So about 10 questions, and they're all conceptual questions. There's no calculations involved. Questions like let me just think. I don't know. What percentage of data is between Q3 and the median? And you would tell me between Q3 and the median, 25% of the data, okay? Or maybe it would ask you approximately what percentage of data in a normal model is within 1 standard deviation of the mean. And you would say around 68%, okay? Things like that. If event A and B have a probability of 0 of happening together, that means A and B are mutually exclusive. Okay, so just so the questions like that, maybe about 10 of them from before the midterm. There aren't calculations involved, but conceptual things that you either you know or you don't. Okay. Today I'm going to go over a few definitions and concepts regarding sampling methods. There will be 4 questions on that. Okay. Everything else, so the other 36 problems, will all be from basically chapters 7, 8, and 9, covering things like hypothesis tests and confidence intervals, both for proportions, for means. You might have 1 sample, you might have 2 samples. Okay, so you have a bunch of different those things. Very similar to the quiz you had tonight. I'll have a scenario set up, and then I'll have maybe 3 or 4 questions related to that setup.
Yeah, more questions on chapters 7, 8, and 9 in class on 1 through 6?
1 through 6, chapters 1 through 6 are covered in the 10 questions that I'm going to ask. Okay? Yes?
So normally we would have gotten our quizzes back and had that extra day, right?
Right. So what I'm going to do right now is I'm going to go over all of the answers to the quiz that you took today, because I know you don't, because you're not going to get the quiz back in time for to study from. Okay, so I'll put the write the question up, and we'll go over the quiz. Okay, so that way you can learn from that. Yes.
Will we be getting like a little progress report like we did last time for the midterm?
Yes. So I will get your quizzes graded as soon as possible, and I will provide a progress report before you take the final that says, in order to get a passing grade, in order to get a C, you need to score this much on the final. If you want a B, you need to score this much on the final. If you want an A, you need to score this much on the final. Okay. For some of you, it will say if you want an A, you need 130% on the final. Okay. The highest you can get on the final would be 110%. So if it says you need 130%, you can't get an A. All right. So.
Say no till you try.
Huh?
Don't say no until you try.
Don't say no. Okay. Well, I will say with the grading rubric that I have, it might be mathematically impossible for you to get an A based on this grading scheme. But
You drop the lowest quiz score?
I will drop the lowest quiz score. So in that progress report, I will say these are your 4 quiz scores. I've dropped the lowest, so your 3 remaining quiz scores is this, and that turns into a quiz average of this. And taking that into account, your total grade before the final exam is this. Okay? Yes.
The final exam is gonna be similar to the sample final exam.
In my opinion, the sample final exam and the final exam are very similar. Okay, of course, all of the problems are different, and the numbers are different. But in terms of the types of problems and the types of questions, I feel they are similar. Yes.
If we scored over 100% on all the quizzes, does that impact our grade over 20%?
I'm sorry?
Does that impact our grade over 20%?
Yeah, so the quizzes are worth 20% of your grade. So if you scored 30 on all the quizzes, or at least 3 of the quizzes, your top 3 quizzes would be an average of 30, total of 120%. So that means I would count a total of 24% towards your final grade, okay? And for some of you, yes, some of you do have a quiz average of 120%, and you will probably finish the class with 105% or 107%, whatever, a very high score. Okay. There's probably two of you in this class, or 3 of you in this class with scores that high. Yeah.
Can we get our progress report emailed, or do we have to inquire in class?
Yeah, I will email out the progress report emails. I know some of you did not receive my progress report email last time I sent them out, so I would say if you don't hear from me by Sunday, okay, send me an email and I will send you a manual report of what you need. Yes? It's all going to be multiple choice, okay? So it's all 50 questions are multiple choice, and that's just so I can get the grading done quickly, okay? Yes?
What are the percentages of before the midterm questions and after the midterm questions? You said this, I said this.
Okay,
75.
so there are 50 questions. 10 of those questions come from before the midterm, so that would be 20%. 20% of the questions are before. 4 out of 50 questions will be stuff I covered today, conceptual things on sampling, and then the other 36 are from chapters 7, 8, and 9. So far, so good? Okay.
It's more of a subjective question.
Okay.
But generally, do people do better on your final than the midterm?
Okay, so the question is, do people do better on the final than the midterm? And the answer is, it depends, okay? And I'll tell you generally what happens. I'm generally not surprised by final exam scores. I'd say, there's 70 people take the final exam. I'd say of those, I'd say about 65 do as I expect them to perform. perform based on their quiz and midterm scores.
Fail horribly.
Some people will do, and of the remaining 5, I'd say a couple will do much better than I expected compared to their previous work, and then a couple people will do much worse than I expected. Okay, and so I might have expected them to get an A, but they do poorly, and it drops their grade down to a B or something like that. So that happens. But generally, people do in accordance to their previous work. Okay. Is that okay?
One page.
Yeah. You get, for your note sheet, you get one 8.5 by 11 sheet of paper, writing on the front and back. Okay.
Wow.
You can write whatever you want. Okay, as long as you make it yourself. All right. You can type. You can use multiple colors. You can draw pictures, whatever you want. Write encouraging notes to yourself, which is probably good also. And but make it yourself. Okay, I don't want to see people have photocopies of other people's note sheets. Another question.
For final, is there a written part on the final? Like
No, it's all multiple choice. Okay. Yes.
We're trying to calculate our grade by ourselves for about the quizzes. Should we count it out of 30 or 25?
Count it out of 25. Okay.
And
So-
then add whatever extra points.
So you take your basically take your top 3 quiz scores, add them up, and then divide that by 75, and that will be your quiz average. Okay, and then you multiply that by 20% because that counts for 20% of your grade. And the homework counts for 10%, audits 5%, midterm 30, and the final exam 35. Yes.
On your progress email, are you gonna send us the grades for the last quiz too?
Yes, I will get this last quiz graded, enter that, and then I'll send out the progress report email. Yes.
And in that, will you send a projected possible grades assume according to what we need to get on the final?
I will not send out projected grades. What I will send out, again, listen up. In this progress report email, what it will say is, if you want to get a C in the class, you need to score at least, 62% on the final exam. If you want a C+, you need a 78% on the final. And if you want a B, you need a 91 on the final. And if you want an A, you need 125 on the final, or something like that. Okay?
Thank you, sir.
Yes. I'm sorry? Yes, there are 50 questions. Each question will be worth 2.2 points, so that really you only need to get, if you get 45 questions correct, you'll get 99%. If you get all 50 questions correct, you'll get 110%. Okay? That's a 10% bonus added to everybody. Okay? Or a 10% multiplicative bonus, I'd say. Alright. Any other questions? Review is tomorrow, 6:30 to 9:30 in Haynes A02. I will be going over all of the answers to the practice final exam. Okay, at this point I will go over today's quiz. There are 2 versions of the quiz. So I will, I'll work through both of them for you guys, if that's okay. Or would you just prefer one version?
Just one.
Both? Not both? Okay. We'll see, we'll see. All right.
Whichever quiz I took.
Whichever quiz you took. All right. Okay, this is question, so version A, okay, and we'll do version A and we'll do version B. Basically, this is the hair loss treatment question, okay? Alright, so it said, so if you have version A, it said group 1 received the placebo. There were a total of 600 volunteers and 252 showed improvement. Group 2 received the treatment.
God bless.
850 volunteers, 408 showed improvement. Okay, and then it says, perform a hypothesis test with significance level 0.05. To see if the new treatment is more effective than placebo. Alright, so first things first. Anytime you do a problem, you first have to identify whether we are dealing with numeric variables or categorical variables. And what is the answer here? Okay. If you end this class and you cannot tell me the difference between a numeric variable and a categorical variable, I feel like you do not deserve to pass, okay? This is we learned this on the first week, okay? All right. So when we're recording data, we're asking, did the volunteers' hair loss improve or did not improve? Okay? So is that a numeric or categorical variable? It's categorical. Okay? And how many samples do we have?
2.
We have 2 samples. So we have categorical 2 samples, okay? If we have a categorical variable, are we dealing with means or proportions? Proportions, okay? So we have proportions, 2 samples, and we're doing a hypothesis test. Is that okay? So the first thing asked, what are the hypotheses, and use symbols, not sentences. Okay, so what are the hypotheses that we will be using? The null hypothesis would be that P1 equals P2, or I'm going to write it as P1 minus P2
That doesn't matter.
equals 0. Alright? That's fine, right? Okay, and then the alternative, okay, the question says to see if treatment is more effective than placebo. Alright? So if the treatment is more effective than placebo, what do we expect? Do we expect more people to show improvement or less people to show improvement? More people to show improvement. Okay, so does that mean P2 should be bigger or smaller than P1?
Bigger.
P2 should be bigger than P1. So that means P1 minus P2 is less than 0. Okay. Is this, are we struggling with this?
Can we also put it as P1 smaller than P2?
I will accept if you write P1 is less than P2. Okay, so that's okay. So these either of these are acceptable answers here. Okay. So when you are writing your hypotheses, you have to read this, okay? And it says more effective than placebo, that the treatment is more effective than placebo. So that means treatment is what? Treatment is represented by P2. Okay, we can see that. Group 2, treatment is represented by P2, and placebo is represented by P1, okay? And more effective, depending on what we're talking about, may mean larger or smaller. In this case, we want more people showing improvement than over here, so that means we're expecting P2 to be bigger than P1. P2. And that's how we get our hypotheses. Okay. B asked, what is the observed difference between proportions? Okay, what is this asking? This is asking what is P1 hat minus P2 hat. Okay. So what is P1 hat? Okay.
600
All right.
divided
So let's take a break and just look at the numbers that we have. We have group 1, that is N1 is equal to 600 and X1 is equal to 252, and over here we have N2 equals 850 and X2 equals 408. So P1 hat is 252 over 600, and P2 hat is 408 divided by 800. Okay? So this is 0.42 minus 0.48, so I get negative 0.06.
Professor,
Yes,
it's 850.
I'm sorry?
It's 850.
Oh, 850. You're right. You're correct.
Is that what is the answer to be P hat? Is that what we just solved for?
No, this is P1 hat minus P2 hat. What is the observed difference between proportions? Okay. The next question asks what is P hat. So it's important that we do not mix up P1 hat, P2 hat, and P hat. And I know there's so many P's and so many hats. But don't mix these up, okay?
Bless you.
Okay. Next question said, what is P hat? Okay. So P hat, we know is x1 plus x2 divided by the sum total n1 plus n2. Okay. Notice again that we add the top and then we add the bottom and then we take the and then we divide. Don't do x1 over n1 plus x2 over n2. Okay, that's not correct. 252 plus 408 divided by 600 . Okay, is that what we get? And then we ask, what is the test statistic. Okay? The test statistic is because the proportions is z, and we do p1 hat minus p2 hat, technically minus 0 divided by the standard error. Okay? How do we find the standard error? Standard error is given by the ugly formula. P hat times 1 minus P hat. 1 over n1 plus 1 over n2. Okay, so I do this on my calculator.
It's 0.0265 times.
Alright, I'm gonna take your word for that. 0.026 what? 2655? 552? Sure, alright. Great. Okay? And so z over here is going to be 0.42 minus 0.48 divided by this number. Okay, so I get negative 0.06 divided by that thing. What did I do with my calculator? And I get negative 2.26. Okay, so that's my z-score. My test statistic is negative 2.26. Yes?
On my test, I put 0.45, and does it need to be 0.455?
I'll see how much of a difference it makes. I would say if you're going to round to 2 decimals, it should have rounded, I think, to, I don't know. I feel like it should have rounded to 0.46 at least. But we'll see, okay? It probably doesn't make too much of a difference, but I don't know. All right. So then the next part says, what is the p-value? So what do we do now at this point? Okay, we would look this up where? On the z table, okay? And how much do we find in our tail? And negative 2.26. 0.0119. Yep. Okay. Alright, so is that my p-value? Or do I have to double it to get my p-value? Okay. And how do I know that I need to double it to get my p-value? No, actually I leave it.
You leave it.
I leave it, okay? So I don't have a not equal sign, I have a less than sign. So this is my p-value. Okay? So the alternative hypothesis has a less than sign. So we leave 0.0119 as our p-value. Okay, so my p-value equals 0.0119. And So, what do I do with regards to the null hypothesis? Yes. So this point 0119, so part F, 0119 is less than alpha. What is alpha? It says perform with significance 0.05. So is less than 0.05. So we reject the null hypothesis. And this means we do have evidence that, so we do have evidence that what? Yeah, we have evidence that the treatment is more effective than placebo. Okay? Yes?
You know if the other representatives on the same formulation?
I don't. I have not done. So I write these tests and I haven't even come up with the answer key. So let me just do that very quickly. Okay.
That's what I think.
Okay, so for the other one, the z-score ends up being 0.64 or negative 0.64 for oh, you're right. Yeah, okay. The z-score ends up being positive 0.64 for the other one, and so that means your p-value is rather large. I have to look this up in the z-table. Uh, 0.26. Your p-value is equal to 0.26. 26 something. Okay, so then you would not reject the null hypothesis in the other version. Okay, I don't want to go through the whole process.
Can you just go through the what the hypothesis looks like at the beginning?
So for the other one, it says group 1 received the treatment. Okay. So in the other version of the quiz, group 1 received the treatment and group 2 received the placebo. So then these would switch directions. So if you had version B, we're looking for P1 greater than P2, okay? For the hair loss problems. Okay. How are we feeling?
Yes.
Okay?
Hanging in there.
Alright, yeah, I'll just do one version of the quiz. So I did version A there, and then the other problem we'll do version B. Womp, womp, womp. Okay.
SpongeBob generation.
What's that?
SpongeBob generation.
Is since that trombone, that's been around for a while.
It's like a normal curve where you wrote like -22.
Yeah.
What is the center?
The center of the normal curve would be 0. Okay, so we will do version B, and it says a man claims that the average age a woman first gets married is 26 years in the U.S. Okay. The average age of first marriage is 26. And we took a random sample of 34 women. And the average age is 27.8 years, with standard deviation equal to 3.2 years. Alright, and then we say conduct a hypothesis test to see if the man's claim is wrong. Okay. Are we dealing with numeric or categorical variables? Numeric. We're looking at the age of first marriage. So that's numeric. And do we have one sample or two samples? One sample. Okay. So, what are our hypotheses? So not HO equals, but HO is, the null hypothesis states that mu, the average age of first marriage, is equal to 26, and the alternative would be that mu is not 26, okay? Because it just says, test to see if the man's claim is wrong. We're not asking, is his claim too high or is his claim too low? We're just asking, is his claim wrong? Okay? What is the standard error? It asks, what is the standard error? For one sample, numeric variable, right? So I should write that we have one sample, and we're dealing with a numeric variable. The standard error is S over the square root of n. So in this case, 3.2 divided by the square root of 34. .5488. Okay. And the test statistic what is our X bar?
27.8.
27.8. This is the average from our sample. The mu that's written in our hypothesis is 26, and our standard error 5488. Okay, so I get 1.8 divided by 0.5488, and I get a test statistic of 3.28. How many degrees of freedom do I have?
33.
So I have 33 degrees of freedom, but we don't see 33 degrees of freedom in the table, so we use 30 degrees of freedom. Degrees of freedom equals 33, but we use 30 degrees of freedom, and we're looking for 3.28. And what do we find? So 3.28 is between 3.385 and 2.750. Okay? 2.750 is less than 3.28, which is less than 3.385. 3.385 corresponds to T.001, and this over here corresponds to T.005. So that means my tail area is going to be bigger than 0.001, but less than 0.005. You got that right?
Yeah.
Okay. Is my tail area my p-value, or do I have to double it?
Oh, that's
Okay. So I have to double this because my my alternative hypothesis has a not equal sign. Okay. So I have
like 30%, 70% old, new.
Yeah, let's have the old stuff.
Like 20%.
They should have all
Come
the
on,
answers be
give us
A.
like a little bit of that leeway.
Okay.
Please.
You get 20% old and I don't know, 72% new, and
Fine with that.
8% whatever the stuff. Okay. This week, just practice. Do that practice final exam, and write up. Make up your own problems and work through them, and you get the hang of it. Everything feels awkward and clumsy the first few times around. Okay. But then with practice, you get better at it. Okay.
So
Yes.
those definitions that you said you're gonna give us for chapter 12, right?
Yeah. I'll do that after the quiz.
Are they gonna be multiple choice definitions then? 'Cause-
So, okay, in a few minutes after I'm done with this quiz,
Okay. Great.
I'm gonna say, I forget what I was gonna say. Okay, I'm gonna go over sampling instructions. Okay, sampling methods. Okay, and so there will be a little section where I describe something and I say what sampling method was used here. Okay, and I'll do a few examples like that in class. So my p-value is between 0.01 and 0.002. So this means I reject my null hypothesis. And we say we have evidence that what? That the man's claim is wrong. I think in truth, though, in the United States, the average age of first marriage for women is around 26. Yeah.
Could your p-value reasonably be like 0.007?
You mean? I mean, yes, it could be, but we don't want to give precise answers if we don't really know the precise number.
But then, if it could be that, couldn't it also be greater than alpha?
No, you're saying 0.007, which is most definitely less than 0.05.
Oh,
Yeah.
0.005, never mind.
Yes.
When you do the greater than signs for the area, and then you switched it the other, you switched the signs the other way to correspond to the T.
Yeah, tail.
So that's just what you do when you find.
Right, because for one number, their test statistic, when we look at our test statistic, the bigger the test statistic, the smaller the tail area. As the test statistic gets larger, the tail areas get smaller. So, so if things are getting bigger for one of these things, then that means they're getting smaller for the other. Yeah, please see.
I also just say, like, think of it logically, like, you can't be bigger than 0.005 and less than 0.001.
Right, so it's just the numbers have to go in order, right? If you're not sure, if you just see these three numbers, okay, and you have Pac-Man and you're trying to figure out less than or greater than, you know, this has to go this way because the alligator eats the bigger number. And then over here, you can't do this. It has to go this way, okay? So just for the numbers to line up. We have to do that. Yes.
But so if the numbers are reversed, but the symbols are still going that way, it's okay, right? Or does it?
Yeah, I mean, if you put the numbers around, so you can order them, you know, small, medium, large, or you can order them large, medium, small, and that's fine as long as the alligator mouth is eating the bigger one. That's fine. Okay. Good.
Actually, I have a question about the second question, part B. I don't exactly get what. Oh, in test B, I guess. I don't exactly get what that question was asking.
What is the p-value, or?
No. It's the second question.
What's the standard error?
No. It's the interval question.
Oh, the
and
interval.
It's the B part of it. I don't exactly get what that is.
Well, is there evidence that it's different? Yeah. So we'll do this one now. Okay. So this, I'll go back to version A. Version A and version B are very similar. I just changed the standard deviation part. Okay, so it said we have 60 randomly selected cattle. And the average weight is 1,660 pounds. Standard deviation, 185 pounds. And we're going to make a 95% confidence interval. Okay, so here we have one sample, numeric variable, we're talking about weight, okay? Numeric variable, and we're making a confidence interval. So that's going to be x bar plus or minus t star times our standard error, which is s over the square root of n. Okay, what is our x bar? 1660. What's our s? 185. And what's n? 60. Okay. Now we have to look up t star. What is t star? So to figure out t star, we have to figure out our degrees of freedom. How many degrees of freedom do we have? 59, right? N minus 1. So we have 59 degrees of freedom. So when we go to our table, how many degrees of freedom do we use? 50, okay? So degrees of freedom is equal to 59, but we use 50 degrees of freedom on the table. And so we look at 50 degrees of freedom and a 95% interval. What is the t star that I'm using?
2.009.
2.009, great. So I just put everything together and I get 1660 plus or minus 2.009 times 185 divided by the square root of 60.
Question.
Yes?
Why is it 60 instead of, I'm sorry, 50 instead of 60? Oh, you round down.
We always round down. If you can't find your exact degrees of freedom, always round down. That's just the rule.
That's not what Americans have. Restricting freedom.
Or we're not restricting freedom. It's just we have a junky table.
Instead of 60, you get 50.
Okay. It's a safety precaution. It's a safety precaution. Okay. It says, all right, if you have paper, or if you have a material that will combust into flames at 1,899 degrees, okay. Do you set your oven temperature to 1850 or set your oven temperature to 1900? You'd always round down just to be safe, okay? That's probably true, but you might also.
Bake 20 minutes, like what, 500 degrees?
I have no idea what we're talking about anymore, but that's all right. Okay, so I get 1660 plus or minus 47.98. So okay, so this is my confidence interval, 1612 to 1708, basically. Is that okay? And then part B, the second part said, is this evidence that the average weight is different from 1720? Okay. What's our answer? So my confidence interval goes from 1612 to basically 1708. Is this evidence that the average weight is different from 1720? Yes, because 1720 is not in my interval. This is the range of plausible values. This is the interval of plausible values. 1720 is not in that range of plausible values, so we have evidence. Yes, we have evidence that the average is not 1720. But is it possible that the average is actually 1720? It is possible. It's just unlikely that our sample would produce values as low as 1660 as the average.
For test B, is it the same answer, or is it?
Yes. I don't quite remember. Let me just check. No, the test B asked, is it different from 1700? And 1700 is in the interval, so you don't have evidence that it's different. Okay. Okay. How are we feeling? Good? Yes, Zayed.
You said we don't have evidence because it's not in our intervals.
Because 1720 is not inside the interval.
No, you said that. Just saying that. We don't have evidence because 1720 is not between our intervals. We got that correct?
Yeah, that would be correct. Yes. Okay, and if the number is within your interval, then you don't have evidence that it's different. Okay, is that all right? Going over the quiz? Are we feeling okay? So I'll cover the stuff from chapter 12. I will start doing some review stuff today, and then tomorrow in the review session I'll go over all of the practice final exam. Before we do that though, I have to do instructor evaluations here. Okay? Yeah. Let me pause the video.